Ever wonder how the plastic items you use every day are made? From your phone case to your car's dashboard, the answer is usually a plastic mold. Think of it as a high-tech cookie cutter for products. It's a precisely shaped steel or aluminum cavity, the master template for a part. By forcing molten plastic into this cavity under immense pressure, we can create complex and consistent parts over and over. This process is the backbone of modern manufacturing, allowing us to produce everyday items quickly, affordably, and at a massive scale. The most common method is injection molding. It starts with small plastic pellets, which are fed into a heated barrel. Inside, a rotating screw melts them into a hot, thick liquid. Once enough plastic is melted, the injection phase begins. The two halves of the steel mold are clamped together with immense force. Then, the screw acts like a plunger, rapidly forcing a precise amount of molten plastic, called a shot, into the mold's cavity at extremely high pressure. Next comes cooling. The hot plastic inside the mold must solidify. To speed this up, cooling channels circulate water or oil through the mold, drawing heat away. This is often the most time-consuming part of the cycle. Finally, ejection. Once the part is solid, the mold opens and ejector pins push the finished piece out. The entire cycle, from clamping to ejection, can take just seconds to a couple of minutes, and then it immediately repeats, making it incredibly efficient for mass production. The magic is in the mold itself. Its two main halves are the cavity and the core. The cavity forms the exterior surface, while the core forms the interior shape. When they close, they create the part's exact geometry. To get plastic inside, runners act as a delivery system, guiding it to a gate, the entry point into the cavity. As plastic rushes in, air escapes through tiny vents, preventing trapped air bubbles. We already mentioned the cooling channels that regulate temperature and the ejector pins that push the part out. All these elements must work in perfect harmony. Of course, the material matters. There are thousands of plastics with unique properties. Polypropylene, or PP, is tough and flexible, used for food containers. Acrylonitrile butadiene, styrene, or ABS, is rigid and strong. It's what Lego bricks are made of. And polycarbonate, or PC, is transparent and impact-resistant, perfect for safety glasses. Choosing the right plastic depends entirely on the product's application. Does it need to be flexible or rigid, clear or opaque, withstand heat or chemicals? While injection molding is king, other methods exist for specific jobs. Blow molding inflates a tube of hot plastic like a balloon to make bottles. Compression molding squeezes plastic into shape, used for large, strong parts, and rotational molding is for huge hollow items like kayaks, by tumbling plastic powder inside a heated rotating mold. Each method is tailored for different shapes, sizes, and volumes. To ensure a part can be molded successfully, designers follow key rules. For example, vertical walls need a slight taper called a draft angle, so the part can be easily released from the mold. Another rule is maintaining a uniform wall thickness. If one area is much thicker than another, it cools slower, which can cause ugly depressions called sink marks. Features like ribs add strength without adding thickness, while bosses are used as mounting points for screws. Getting these details right is crucial to avoiding costly problems, but things can go wrong. A short shot is an incomplete part from too little plastic. Flash is excess plastic that seeps out of the mold, and warpage happens when uneven cooling causes the part to bend or twist. Quality control technicians constantly monitor the process to catch these defects early and ensure every product meets its required specifications. This brings us to cost and speed. The biggest upfront investment is the mold itself, which can cost from thousands to hundreds of thousands of dollars. This is the tooling cost. However, once the mold is made, the per-part cost becomes incredibly low, often just pennies. The high speed of the process means you can produce millions of parts quickly. This makes injection molding unbeatable for mass production, where the high initial tooling cost is spread out over a massive number of units. So, from a simple bottle cap to intricate electronics, plastic molding is the invisible force that shapes our material world. It's a sophisticated dance of temperature, pressure, and precision engineering. Next time you pick up a plastic item, take a closer look. You might see the faint line where the mold halves met, or the tiny circle where the plastic was injected, and you'll know that a remarkable custom-built mold made it all possible.